Hello all. So here one more problem in the game theory when saddle point doesn't exist. So this is a problem. So let us solve the problem. So the game is outcomes: player A 5 1 3 4. So this is the outcomes. It is 2 by 2 matrix. So here we'll try to find out the row minimum and column maximum. So row minimum is 1 and 3, column maximum is 5 and 4. So here maximin is identified as 3, maximin, and 4 is the minimax. 4 is the minimax. So maximin is not equal to minimax. So there is no pure strategy, and also saddle point doesn't exist. So what we have to do? We have to find the oddments. So 5 1 3 4. 5 1 3 4. So we have to find the oddments. So 5 minus 1 is 4, 4 minus 3 is 1. In the same way, 5 minus 3 is 2, 4 minus 1 is 3. So oddments. So this I am considering as probability 1, probability 2, probability for columns Q1 and Q2. So the probability 1 plus 4, 1 by 5. Definitely the probability for P2 will be 4 by 5. So 4, 1 plus 4, that is equals to 4 by 5. So Q1, 3 divided by 3 plus 2, that will be 3 by 5. 2 divided by 3 plus 2, that is equals to 2 by 5. So we need to find out the value of the game. Value of the game. So that is equals to 5 into 1 plus 3 into 4, 1 into 1, 4 into 4. 5 into 3, 5 into 3, 1 into 2, 3 into 3 plus 4 into 2. So this is how we can calculate. I will take any two will solve. In the previous video already I have demonstrated how you will get the value of the game. For all the 4 outcomes it will be the same. So here I am taking this one, 5 into 1 plus 3 into 4 divided by 1 plus 4. So 5 1 plus 4 3 is 12 by 5. So 17 by 5, that is equals to 3.4. So next, one row done. Let us see the column. 5 into 3 plus 1 into 2 by 3 plus 2. 15 plus 2 by 5. So 17 by 5, so 3.4. So here what I have done, 5 into 1 plus 3 into 4, you got 3.4. In the same way, 1 into 1 plus 4 into 4, you will get the 3.4. So one I have done here only for 2, so we got same value, hence value of the game is equals to 3.4. Thank you.